next unit, the next unit that we'll be going over is stoichiometry. Okay, stoichiometry is the branch of chemistry which deals with calculations, right? Okay, for example, if you have a chemical reaction and you have a certain mass of a chemical substance, and if you reacted with another chemical substance of a certain mass, so how much of the product will you form? Okay, so these all of these calculations that you do are all included under the heading of stoichiometry. So in this segment of stoichiometry, we'll go over uh, relative masses of atoms and molecules, otherwise abbreviated as MR and AR. And we'll also briefly go over the mole concept. We'll discuss mole in more detail in the next class next week, inshallah, but we'll go over the concept. Okay, so let's advance to the next slide. So this is the content. We'll go over the formula. Uh, we'll go over the formulae, we'll go over the relative masses of atoms and molecules, and we'll also just lightly touch mole and the Avogadro constant. So let's just, before we start mole, let's just talk about the relative atomic mass. So what is the relative atomic mass? We discussed this in one of our initial classes, that the average mass of the isotopes of an element compared to 1/12 of the mass of a carbon atom, specifically the atom of carbon-12, is known as the relative atomic mass. And what that means is, okay, if you have a sample of an element, so for example, if you have oxygen gas trapped in a container and you have oxygen atoms, so oxygen and every element has its own set of isotopes, right? So uh, what happens is, okay, every isotopes has a different mass. Okay, every isotope has its own different mass, but they have the same proton number. So the weighted average of the atomic masses of all of those isotopes combined is known as the relative atomic mass, the AR, and compared to the mass of 1/12 the mass of a carbon-12 atom. Okay. So examples, the AR of oxygen is 16, the AR of chlorine is 35. So basically the number which is written just below the chemical symbol of that element in the periodic table is known as the relative atomic mass. Okay, AR भी कहते हैं इसको. If you look at the periodic table, so I need you guys to open up the periodic table on your phones. Okay, just go on Google Images and just open up the periodic table. Okay, in periodic table you can see that you have the chemical symbols uh, arranged in order of increasing atomic number, and then you have two numbers associated with that chemical symbol. So you have the atomic number, which is also called the proton number, and then you have the atomic mass or the AR, right? So the bigger of the two numbers is the atomic mass. So again, that's equal to the number of protons plus the neutrons. Okay. So then we talk about relative molecular mass. Say, so for example, if we have individual atoms, like we have oxygen here, we have chlorine. So the masses of these individual atoms, as seen on the periodic table, those are the relative atomic masses. But what if these atoms bond together to form compounds, right? So for example, uh, hydrogen and oxygen bond to form a really common compound which makes up 70% of our planet, and it also makes up more than 60% of our bodies, known as water. So water is a molecule, right? So the sum of the masses of the individual atoms in this molecule is known as a relative molecular mass, or otherwise known as an MR. Okay? So water over here contains H2O, right? So it contains two hydrogen atoms and it contains one oxygen atom. So the AR of hydrogen, what is the AR of hydrogen? It is one, right? Hydrogen has a mass of one. AR of oxygen, on the other hand, is uh, 16, right, on the periodic table. So since water has two hydrogen atoms, so we'll add one plus one, right? So we'll add one and one. These are the two hydrogen atoms. So that makes up the H2, right? and then we have 16, so that makes up the O, and this equates to a relative molecular mass, or MR. It's abbreviated as MR. Okay? Don't confuse it with Mr. So MR of water is 18. So whenever you're asked, okay, what is the relative molecular mass of um, a compound, so you just add up the individual ARs of the atoms which are involved in that molecule. So हमने AR hydrogen के add की, oxygen के AR add कर दी, and then that makes up the MR of water. So ARs add up to form MR. Okay, so mole. Let's go over the mole. So अभी तक किसी का कोई भी question MR or AR? I hope you guys get what is MR and AR. It's pretty trivial.
No question.
Okay, and what about Azlan, Maham? सबको clear है?
Yeah, everything's clear.
Okay, perfect. Same. So let's go with the mole. So mole जो है ना, it is the most important concept in chemistry. ठीक है? Specifically, to perform all stoichiometric calculations, you need to know what is the mole, right? So the mole, by definition, is the amount of substance. ठीक है? The amount of substance is defined as the mole, right? So the mole is a unit of measurement in chemistry used to express amounts of a chemical substance. Okay, so if you talk about the mole, so a mole is the amount of substance, right? What is the Avogadro's constant? So Avogadro was basically a scientist who measured how many individual atoms are there in a mole. So if you take a mole of carbon, if you take a mole of oxygen, if you take a mole of nitrogen, if you take a mole of maybe chlorine. So if one mole the amount of substance, you know. So if you have like a mole of carbon, 1 mole of carbon. So you have 1 mole of carbon, right? That's the amount of carbon you have. And then you have 1 mole of oxygen, so that's the amount of oxygen that you have. If you have 5 moles of nitrogen, that's the amount of nitrogen you have, right? So it's just the amount. But if you like zoom in, so if you have your box, it contains like multiple, many small oxygen atoms, right? So for example, we say, okay, this box contains 1 mole of oxygen atoms, right? But if you just count the atoms in this box, say, you know that this box contains 1 mole of oxygen, right? But if you count the individual atoms in this box, so you'll find that there are 6.02 into 10 power 23 particles. Okay, 6.02 into 10 power 23 atoms of oxygen in this box. So it's a rule that 1 mole of any substance, okay, no matter what, 1 mole of water, 1 mole of carbon dioxide, 1 mole of hydrochloric acid, 1 mole of nitrogen gas, 1 mole of oxygen, जो भी है, ठीक है, if I say I have 1 mole of carbon dioxide, that means I have 6.02 into 10 power 23 carbon dioxide molecules in that box. Okay, and that is what is known as the Avogadro constant. So Avogadro constant की importance here it allows chemists to convert between the number of particles and the amount of substance in moles, right? So if you want to calculate the number of particles, so you'll just multiply the moles, okay, by the Avogadro's constant. Okay, Avogadro's constant is abbreviated as Na. So mole times Avogadro's constant is the number of particles. So if you have 2 moles of carbon dioxide, so it would be like 2 times 6 into 6.02 to 10 power 23 particles, right? So that's how many particles there will be in 2 moles of carbon dioxide. So that's pretty simple. Okay, let's move on. So that's the exact concept that which I just discussed. 1 mole of any substance whatsoever, if it's 1 mole, it will contain 6.02 into 10 power 23 particles. So yeah, so the masses, if you look at the periodic table, so this is a very important concept and not many people get it right. ठीक है, बहुत सारे लोगों को A levels तक नहीं पता होता है चीज. तो जो periodic table है ना, the periodic table contains the list of elements, right? And उसमें नीचे जो उनकी AR लिखी हुई है ना, ठीक है, AR. So Rafi, can you just tell me what is the AR of oxygen? ऑक्सीजन एटम की AR क्या होती है?
एयर ऑक्सीजन की 16।
16, ठीक है, एग्जैक्टली. सो AR ऑफ ऑक्सीजन इज 16. सिर्फ पीरियोडिक टेबल से देख के बताना है. सो 16 इज द AR ऑफ ऑक्सीजन एटम. अभी सिर्फ 16 नहीं है, दिस इज 16 ग्राम्स, ठीक है. अच्छा, अब बंदा अगर इमेजिन करे, ठीक है, 16 ग्राम्स को, 16 ग्राम्स पता है कितना होता है? 16 ग्राम्स इज इक्विवेलेंट टू अ टी स्पून. सही है, टी स्पून ऑफ ऑक्सीजन. सही है. तो हमें ये लगता है कि पीरियोडिक टेबल में जो भी एलिमेंट्स लिखे हुए हैं, उसमें जो नीचे नंबर लिखा हुआ है 16, दैट इज द मास ऑफ वन एटम ऑफ ऑक्सीजन. सही है. वेयर एज दिस इज नॉट द मास ऑफ वन एटम ऑफ ऑक्सीजन. जो 16 लिखा है, 16 ग्राम का ऑक्सीजन एटम हो सकता है? सोचो, 16 ग्राम का ऑक्सीजन एटम इतना मतलब भारी होता है. 16 ग्राम नजर आता है, 16 ग्राम सामने. 16 ग्राम इज अ टेबल स्पून, सॉरी, टी स्पून ऑफ सॉल्ट, equivalent to teaspoon of salt. You cannot see atoms, right? Atoms की तो mass, individual atoms की mass तो बहुत ज्यादा कम होती है, right? Individual atoms way less than what their listed AR is on the periodic table, right? So फिर ये masses क्या होंगी? What are these masses actually? These masses which are listed on the periodic table, these are the ARs, ठीक है, the relative atomic masses. और 16 ग्राम ऑफ ऑक्सीजन अगर हम लेंगे ना, दैट इज इक्वल टू 1 मोल ऑफ ऑक्सीजन, ठीक है. और अगर मैं इसको एवोगाड्रोस नंबर में लिखना चाहूँ, सो हाउ मेनी, कितने एटम चाहिए होंगे मुझे टू अचीव 16 ग्राम्स? अजलान, आई थिंक योर माइक इज नॉट वर्किंग. कैन यू कम अगेन?
No, I don't understand.
Okay, I'll explain again. Rafi, you were about to say something.
No.
अच्छा, सो जो ऑक्सीजन है, जो आपकी सारी एटॉमिक मासेस लिखी हुई ना पीरियोडिक टेबल में, so let's just take another example, ठीक है, बल्कि we'll just work with this example. So ऑक्सीजन है, ऑक्सीजन की जो मास लिखी हुई है on the periodic table is 16 grams, right? 16 grams. 16 grams is पता है equal to a teaspoon. और टीस्पून तो नजर आता है आपको कि टीस्पून ऑफ एनी सब्सटेंस, आप टीस्पून ऑफ शुगर लें, टीस्पून ऑफ सॉल्ट लें, यू कैन सी 16 grams. बट many people tend to assume कि जो ओ के नीचे ये 16 लिखा हुआ है ना, और 8 ऊपर लिखा होता है इस तरह से पीरियोडिक टेबल में, दिस 16 is the mass of one atom, one single tiny atom of oxygen. Well, that's not true. ठीक है. This mass right here is equal to the mass of actually 1 mole of oxygen. अगर हम 1 mole लेंगे ना ऑक्सीजन का, this is the mass of 1 mole of oxygen, not one atom. And according to the Avogadro's rule, how many atoms will this 1 mole contain? Rafi?
16.
9. 6 into 10 power 23. मैंने क्या बताया था? 1 mole
Oh.
of any substance contains 6 into 10 power 23 particles, atoms, molecules, whatever. ठीक है, यूनिट्स बस. तो
ये
इसका
इधर इज
मतलब
इक्वल टू, इधर इज इक्वल टू 12 ग्राम्स क्यों लिखा है?
इक्वल्स टू 12 टाइम्स. कहाँ लिखा है?
12 ग्राम्स।
12 नहीं, ये 16 है. ओ अच्छा, ये तो अलग कार्बन का दिया हुआ है. ये कार्बन की एग्जांपल है. ठीक है, मैं आपको ऑक्सीजन की एग्जांपल पढ़ा रहा हूँ. दिस इज कार्बन एग्जांपल. सो ऑक्सीजन जो है, इसका 1 मोल कंटेन्स हाउ मेनी? 6 into 10 power 23. अभी पता नहीं क्यों कर रहा है पेन के साथ ये, आई डोंट नो, बट जस्ट इग्नोर दिस. ओके. सो 1 mole of oxygen contains 6 into 10 power 23 oxygen atoms, right? So iska matlab, if you'll have these many oxygen atoms, then अगर आप उन 6 into 10 power 23 oxygen atoms को weigh करेंगे ना, so they will be equal to how many grams?
16.
Exactly, ठीक है, 16 grams. ठीक है, अब समझ आ गया? अजलान, माहम, आपको समझ आ गया?
जी.
जी.
राइट, ठीक है. एंड अजलान, आपको समझ आया? आई डिडंट हियर यू.
Yes.
Okay, perfect. So now you get the concept, right? So every atom on the periodic table जो लिखा हुआ है ना, it's not actually the mass of one atom. एक atom की mass तो एक nanograms के अंदर होगी ना. It's nanogram भी नहीं बल्कि picograms के अंदर होगी. इतना छोटा atom होता है, you cannot even feel it, right? Can you feel the individual atoms of oxygen around you? No, you cannot feel the individual atoms of oxygen around you in your atmosphere. कि वो तो बहुत छोटे छोटे हैं, उनकी mass भी ज्यादा नहीं, right? But if you'll take 6 into 10 power 23 atoms or 1 mole of oxygen, that will weigh 16 grams, right? So these masses are actually the masses of 1 mole of that substance. So सारी लिखी हुई ना. अब अगर सोडियम की मैं देखूं, तो ये सोडियम, so Na, and it says like 23. Oh my god, ये क्यों कर रहा है? I don't know. So Na, and then we have 23 and 11. ठीक है? So ये जो 23 है ना, this is the mass of 1 mole of sodium equals to, if you'll take like 6 into 10 power 23 atoms of sodium, so they will weigh 23 grams. समझ आई? So this is the concept. So all of these masses are basically the relative atomic masses or the molar masses of those substances. Okay, so sorry, not the molar masses, the relative atomic masses. Okay, so now let's talk about molar mass, how to calculate the moles, right? So moles का simple जो formula है ना, if you want to calculate how many moles of a substance you have, so simple, the mass of a substance in grams divided by the number of moles, ठीक है? So that equals the molar mass, right? So the moles equals the mass of a substance, जितनी भी mass है in grams, ठीक है? Make sure it's in grams, ठीक है? This is very important. कभी कभी Cambridge exam में kilograms में दी होती mass and you have to convert it. So mass in grams divided by the molar mass, ठीक है? So molar mass क्या हो जाएगी? For example, the AR of that atom, or if it's a molecule, so it will be AR होगी MR. MR, ठीक है? So let's say I want to calculate the moles in, if I take like 5 grams of sodium, ठीक है? If I take 5 grams of sodium, so I just ignore these examples for a while, ठीक है? ये वाले आपने ignore कर दे examples. मैं अपने आप simple examples कर रहा हूँ. If I take 5 grams of sodium, I want to know how many moles does 5 grams of sodium contain. So what I'll do is, I know that I have 5 grams of sodium, so I have mass in grams. I'll divide it by its AR, ठीक है? So because sodium पे चाहिए हमें. So 5, what is the AR of sodium? Azlan, बल्कि maham, what is the AR of sodium? Periodic table से बताना है देखो.
11.
No, 11 is the atomic number. This is the AR. The larger of the two numbers is the AR. 23 is the AR of sodium, ठीक है? So if I have 5 grams of sodium and I want to know how many moles of sodium I have, so I'll just divide 5, the mass in grams, divided by the AR. So let's just divide it. So I'll just open up my calculator here. So 5 grams of sodium and then divided by 23. That equals 0.217 moles. ठीक है? 0.217 moles. अच्छा, अब now if I want to know, ये सवाल है अजलान से. Now if I want to know कि how many atoms are there in 0.217 moles, what will I do?
You'll divide the mass by the um you'll divide the mass by the atomic number.
Yeah, that is the moles. Okay, you're right that way. That's how you'll get the moles, which we just calculated by dividing the mass by the number, the mass number. But how many particles, if I want to know okay, what is the number of atoms in this 5 gram sample or in 0.217 moles of sodium, what will I do?
Multiply it by 50.5.
You'll multiply by what?
58.5.
With can you you're cutting off, just say. You'll multiply by what? फिर से बोलो.
Yeah. Blah.
Acha, I think your mic is not working. So if you want to find the number of atoms in this 5 gram sample or in 0.217 mole, we'll simply multiply it by the Avogadro's number. Okay? You know that 1 mole of any substance contains 6.02 into 10 power 23 particles, right? So if 1 mole contains 6.02 into 10 power 23 particles, how many particles in 0.217? So simple 0.217 multiplied by the Avogadro's number. Simple. Okay. And I'll just multiply by the Avogadro's number here. So just open up my calculator. So that gives me 1.3 times 10 power 23. That's how many particles of sodium there are in 5 gram of sodium or 0.217 mole of sodium. Understood? अभी तक समझ आया? रफी, आपको समझ आया? माहम?
जी
जी
Okay, perfect. And what about you, Azlan?
Yeah.
सही, perfect. सही. So I'm just assuming कि आप लोगों को समझ आ गया. I'll send you questions, ठीक है, और आप लोग वो questions solve करेंगे. सही है. And by the next week they should be solved. So I have topical past papers, and you'll solve them. Some of the questions in those past papers are really hard, so I don't expect you to solve them yet until आप लोगों को और concepts ही पढ़ाए जाएं. But you have to solve some questions which I'll send you, ठीक है. So this is like the same thing which I just told you. If you want to calculate the moles, you just divide the mass of substance that you have, and you'll divide it by the molar mass, which you'll just copy from the periodic table. Okay. So this is an example calculation. If you have 11.5 grams of sodium, and you need to know how many moles of sodium you have, so you'll just divide 11.5 grams by 23, and you'll get 0.5 moles. And if you want to know the particles in the 0.5 moles, you just simply multiply 0.5 by the Avogadro's number. Okay? And you'll get the number of particles. That will be equal to 3.02 into 10 power 23. Right? Somewhere around 3 into 10 power 23 particles. Right? So and that's all for the mole concept. If you have any questions, so you may ask. आज की थोड़ी सी क्लास लंबी हो गई थी.